Hey guys, it's Shah here at the Tech Book, and today's video we're going to be making a quicksort algorithm in Python. We're going to be using something called recursion, something which I've explained in my previous videos, and it's been pretty long since I've made one, so let's go ahead and do that. Okay, so how does quicksort work? You can check this on YouTube if my explanation isn't great. This will be a very brief explanation. If you want, just comment it down below and I will put another video that will explain in depth about how quicksort works, but this is just a general idea. So how quicksort works is, say you have a list. We've got, imagine 8, 3, 5, 1, 10, 15, 4. Okay. How quicksort works is we're going to use a pivot point. So the pivot point is anything, any of the values in this list. We're just going to use the initial value. And then we're going to say that we want to put everything that's less than the pivot. We need to perform quicksort on that. So we need to perform quicksort on everything that's less than the pivot. The pivot in this case is 8. So what's less than 8? 3, 5, and 1, and 4. So on the left, we're going to have so we need to perform quicksort on the things that are left of 8. So that's 3, 5, 1, and 4. So we need to perform quicksort on 3, 5, 1, and 4. Now what we need to do is, we've got the lower end. We need to also get a taste of the upper end now. So we need to perform quicksort on the upper end. What's greater than 8, 10, and 15? So it would be 10 and 15. Now, we need to perform, because it's recursion, quicksort on these remainder values, correct? So, we're going to perform quicksort on this yet again. So if we perform quicksort on, say, this left region, so QS on the left, we're going to get the pivot as 3, right? Because it's the first value. Now, what that means is our list will look as follows. We need to perform quicksort on 5, 1, 4, and we need to add, obviously, 3, because that's the middle value. Now, 5, 1, 4, are all of these less than 3? Nope, only 1 is. So quicksort of that plus quicksort of 5 and 4. Now, this is just the left side. As you can tell, the right side is already sorted. So if you were to break this down, you'd end up getting quicksort of, so 10 plus the quicksort of 15. Now we know the base case is quicksort of any singular number is the number itself, so 15. Now if we were to simplify this, you can now kind of tell how this works. This would end up making QS of 4, and then you'd have plus 5 here. This will all break down to just making 1, 3, 4, and 5. So this is how it would look in recursion terms, and all of this would just be combined with everything here. So let's go ahead and code it now. So define QS, which is our quicksort. Obviously we're going to take in our list, call it A. Now what we're going to do is we're going to do our base case. Now if the length of A is 1, then what that means is that you've gotten to a singular value, right? So we've gotten to our singular value, so we must return the same value, but it has to be as follows: A of 0. So we're returning the only value that there is, but we're returning it as a list. Now why do we need to return it as a list? Because we need to allow the concatenation of lists. Otherwise we're going to get a nice little error. So else we're going to call the pivot A of 0, like I've been saying the entire time. The pivot is the first value in the list. Now what we need to do is, in order to produce these two things here, so QS of this, and then we have the QS of our side here. So in order to get these two lists, we need to separate out everything that's less than and greater than the pivot. So less than, we're going to assign it a list, and greater than, we're going to assign it a list. Now, for x in range of 0 to the length of A, now we're not going to use 0. Now think about why we're not using 0. Because 0th position is the pivot, right? It is the pivot, hence we're not using it. So for x in range from 1 to the length of A, if A of x, so if the xth value, so x index is less than our pivot, we want to do less than dot append, and we're going to append the value at A of x. Now else we're just going to do greater than dot append a of x. Very straightforward. Now, this makes up our two lists now. Think about it this way. We've gotten to this point. Now, what do we need to do? What do we need to return in order to make sure it does the quick sorting of these recursively? So, very straightforward. Have you noticed how our function takes in a list? We're going to be using that knowledge, and we're just going to do return quicksort bracket less than plus, and then in here we're going to put our pivot, which is, you can call it pivot, plus our quicksort, which is, again, we're performing quicksort of everything that's in the greater than section. And now let's go ahead and print it. If there are errors like usual, we will go through it together. So let's save it and run this. Alright, there's an error. It says list index out of range. Okay, so in order to fix this, so the only time you'd produce this error is when the list is in either 1 or greater than 1, right? So we need to have an elif. We need to check, is our list empty? Because if our list is empty, we want to return the empty set. So as you can see, we've gotten to the right answer. If I just run this a couple of times, so there you go. If you can see on my screen down here, the answer is 1, 3, 4, 5, 8, 10, 15. As you can see, I successfully sorted our input, which was not very pretty. Unsorted as well, of course. And it's managed to sort it in a very short period of time. Quicksort. You may be wondering, why is it called a quicksort? It's because it's fast, I guess. In the worst case scenario, though, so in terms of time complexity wise, it is quite similar to many other algorithms in terms of time complexity. But when it comes to average and best case, it does a very good job of running large numbers. I think order of n squared is its worst case, as I remember, and n log n is probably its average and best case. So something that you want to use to code, basically. So let's walk you through what we did briefly. So first, we defined our two base cases. So if we have a list that's length of a, we just need to return this. Or if we have something that has no size, just return the empty set, basically. Now, what we did after that was we performed, so the real recursion happens here. So what happens here is we're performing quicksort on whatever's less than the pivot and whatever's greater than the pivot. So essentially what we're saying is, okay, I pick a number out, everyone less than the number, go to the left, everyone greater than that number, go to the right, and then we sort out those sub-problems, basically. So as you can see, this breaks up the problem, this last line here, and then it tells them to sort out themselves. Like QS of less than is, you're telling less than to break it down even further by itself, right? You're telling less than to find a new pivot of itself and then break it down further. And that's how it works, essentially. It's basically making pivots and making singular terms as follows in order to build our solution. So that's how recursion works. So I hope you guys enjoyed this video. It's been a long time since I made one. I hope you guys enjoyed it. And now I'm in second year of uni. So if you guys need any assistance for, say, programming or I guess documentation wise, if you want like some advice on what you want to write, go ahead and feel free to ask. How to apply to places maybe you want to know. Feel free to ask me and I will assist you in that. Again, thank you for watching, guys. Like, comment, subscribe.